All right, we are live. Welcome back to the LLM Bootcamp Zero to Hero in LLMs, and I hope everyone are doing all right. And in today's session, we have Shreehari Vaasistha, who is a SD at AI Planet, and we have Chanukya Patnaik, who is the founder and CEO at AI Planet, and we'll learn about what is GenAI Stack. So, talking about GenAI Stack, it is an end-to-end LLM framework that was designed to integrate large language models into your application seamlessly. The main purpose to build this GenAI stack was to bridge the gap between your raw data and actionable insights of responses that application can utilize and leverage the power of LLMs. And in today's session, the main agenda will be why we built GenAI stack and what are the major components that is used to build the GenAI stack and the problems that an LLM face, whether it is hallucination or the computation issues. And we also have a code demo where you will work with GenAI stack components, and then there will be a use case application to get started with it. And without further ado, I leave floor to Chanukya to get started with this session.
Hi everyone. Thanks Tarun for the introduction, and I hope you are doing well. And I'm looking forward to this session. With that, let me just quickly share my screen and get started with it. I hope you're able to see my screen, and I would like to make this session more interactive. And so, feel free to ask any questions that you may have in between. I'll be happy to address them. I think Tarun is there for us to moderate that. And
Yeah, the screen is visible.
Oh, perfect. So with that, let me just get started. So as Tarun has already mentioned, um, both Shreehari and myself will be delivering this session. And with that, let me talk about the problem statement that we are trying to address. Right now, if we look at it, there's a lot of hype about generative AI, and last year alone, I think about $450 billion was spent on AI by enterprises, and this is only going to grow, right? I mean, in the next coming years, and then probably we are going to see it touch about $2 to $3 trillion by end of 2030, and that's very massive, right? But the reality is there is still challenges in terms of adoption of advanced AI models, including that of large language models, right? So one of the major concerns that we keep seeing is about data privacy and IP concerns, and not just that. If we go beyond, there are unknown risks with the LLMs, like LLMs, whatever they throw, they're not often reliable, right? Because they are super creative, and they end up hallucinating a bit, and they end up throwing some unreliable responses. And when we are really specifying some of the regulated industries like banks, healthcare, and all, there, it's all right not to get an answer rather than giving a wrong answer, because it's going to adversely impact the other person who is receiving this response, right? Let's imagine a patient who's receiving some random response from a large language model, which could hurt their emotions, and it can go haywire, right? So there is a lot of uncertainty with LLMs, and even when I talk about most of the industries, they're struggling with finding the starting point, and also finding the right use cases. And then comes the integration complexity, the data privacy, data security, and also eventually, after investing so much, some of the big industry may not even see the impact, right? And then there are always regulations that kick in to be able to ensure all the safety measures are taken in implementing these advanced technologies as well. All right. So these are some of the things that we are going to cover. I'm not saying like, no, we are going to cover all the aspects, but in this session, we would love to cover some of the aspects like hallucinations, as well as contextual awareness of LLMs, and how to bring in factuality and reduce hallucination is something that we are going to extensively talk about, and how we are going to address that, so that we can make LLMs more meaningful and more useful in terms of solving some of the real life challenges out there. So with that, let me quickly summarize about the agenda of the session. Right, so we'll be talking about briefly about LLMs. We'll talk about the limitations on hallucination and contextual awareness. We are going to talk. We are not just going to talk about the limitations. We are also going to talk about how we can overcome these challenges with hallucinations and also contextual awareness, right? And then we'll briefly talk about GenAI stack, and also we'll cover some of the interesting use cases like document search. Like if you have a vast amount of documents, we are going to put up a simple tool that's going to help you search the document and also chat on top of the documents, as well as we are going to chat, build an application where we are going to chat on top of a web page as well, right? So this is our agenda of the session, and we are going to talk about this. First of, what are LLMs? I'm sure some of the attendees out there have gone through the LLM bootcamp, right? So would love to hear from you. What are LLMs? Maybe I'll take a quick pause before even I prompt the answer. Maybe would love to hear some responses as well from the community. Yeah.
Yeah, I'll be adding the questions.
Yeah. Sure. 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 That. Yeah. Probably okay. Let me just quickly move forward with the rest of the slides. Right. I understand there might be a lag between StreamYard and YouTube. So with that, let me talk about LLMs. So first of LLMs, the full form of LLMs is large language models, and they end up producing content that is human like, right? And they can also generate and understand content that is human like. The human like content could be as simple as writing quotes, or it could be about writing books, or novels, or whatever it is, right? And we also write some literatures or even technical documentations or whatever it in our day-to-day lives. And this is what large language models are capable of, which can actually mimic and generate human like content. And they can be used in variety of applications. It could be about simple language translation work, or even question answering, or even summarizing something, or paraphrasing a text, or anything of that sort, right? So it has various level of very high level use cases to very granular level use cases, which can impact certain industries. And what they can do precisely, like, when we talk about what large language models are capable of, is they are capable of generating text, and they're capable of understanding a given text. Let's say you give a context, it understands that fully, and it can actually respond any question on top of it, right? That's where the question and answering comes in. And it can also do several natural language processing tasks. It could be a simple semantic search, to named entity recognition, and many more, right? So it can technically do multiple NLP tasks as well. And with this, let me also talk about what it cannot do, right? I mean, these are some of the nice to have things, nice things that it can do, but obviously, all good technologies have its own limitations. So that's where, let me jump into what the LLMs cannot do at the moment, right? They cannot actually allow you to truly comprehend something, and then they cannot critically think. They are not rational always, and they don't have the factual information as well, right? That's where the contextual awareness limitation is there. If they are trained on a particular data set, they have contextual understanding on that particular data set, and they don't really apply a common sense to understand whether what is the factual information that is available out there. They just think about what they have already known, and they try to give an answer based on their understanding of the given context, and also the trained data that they already have, right? And they can't really make an ethical judgment. So that's something that's still need to be incorporated. So these are some of the drawbacks of large language models, right? Where they are not, while they are super helpful in many ways, at the same time they have their own limitations in many facets, including what I have listed, and then there could be more as well. I'd also love to hear from the community on what all limitations they have seen in the journey. And the main focus of today's session will be more on hallucinations and contextual awareness, to understand, when I say hallucination, what hallucination is, and what are the problems that we are facing with hallucinations, right? At the same time, we'll also talk about contextual awareness and what challenges are there with the contextual awareness, and how we can overcome them. So first off, let's go to hallucinations, right? So when I talk about hallucination, traditionally all the large language models are super cool, undoubtedly, but at the same time, uh, they are super creative, right? They end up generating something out of nothing as well. So with that, let me show you one simple, quick example of hallucination. So here, I just simply threw an example of how does Databricks Dolly provide value to open source community. So this is a simple question I have asked uh, on the OpenAI GPT-3 API, GPT 3.5 API, and this is the response I got. Right, it says Dolly provides value to the open source community by simplifying the process of migrating code from Apache Spark to Databricks. Whereas in reality, when I talk about Databricks Dolly, right? So I'll also show this on both Google search as well as on this thing, right? So when I talk about Databricks Dolly, it's a open source large language model that is introduced by Databricks. Whereas when I ask the same question on ChatGPT, let's say I'm just using the playground of OpenAI, and here if I ask this question, so it is talking about something totally different, right? So when I ran, it gave this particular response. It said that, like, it can help in migrating code and data from Apache Spark to Databricks, whereas it is right now throwing some other response, which is completely different actually. So it is talking about machine learning projects and AI projects and version controlling, acceleration of development, and other things, right? So it is completely different. So here, what actually these large language models are doing is they're hallucinating. They don't even know what the fact is, but based on some of the context that they have been trained on, whether it could be on Databricks or some other, or even here the context could be open source community and other things, based on the knowledge they have about Databricks and open source community, they cooked up some answer, which could in reality be totally incorrect, right? So here, this is a perfect example of hallucination, where a large model has thrown an inaccurate response. Now, the big question is, how do we avoid this? Is a big question, right? That's what we are going to learn in the session on how we are going to reduce hallucination and enhance factuality. And if you ask me, what is the downside of having this hallucination is, for example, I gave a simple informational question. But for example, if I'm talking about the sensitive information of a patient, or if I'm talking about medical report analysis of a patient in healthcare industry, or even about some sanctioned person in a banking industry, then the response that I'm coming from LLM or a large language model is going to be really crucial for the front office to make decisions, right? And if large language model is giving an inaccurate response, and if the decisions are made on inaccurate responses, then the kind of magnitude with which the repercussions would be for these kind of decisions would be very, very huge, right? It's going to be in a much higher magnitude. So that's something that needs to be avoided when we build a technology, and then that's where it's going to be extremely crucial to be able to ensure whatever generative AI applications are built, there we base all our outputs as reliable LLM outputs rather than hallucinated or less relevant outputs, LLM outputs, right? So that's something that we are going to cover. So this is the problem of hallucination. And now comes the contextual awareness, right? Contextual, again, I mean, hallucination is a subset of contextual awareness. That's where, like, you can LLMs can end up generating some inaccurate or false information, as I've shown with Dolly, right? And it can also, like when I talk about the sensitivity to the input wording, right? So instead of giving whatever text I have given, if I change even a very minor word in it, or it can completely change your response, right? So that's where, like, I have put few more things here in this particular document. Let me probably run you through this, right? Sensitivity to input wording. Let's say if you're asking what are environmental impacts of deforestation versus explain the ecological consequences of forest clearance. In both the cases, it'll give you a very comprehensive answer, but it could be very different, right? So that's where, like, based on the input wording, it can completely change the comprehensive answer that it gives. So it may not be consistent always. And also there is absence of verification. So this is something that we have seen with Dolly example as well, right? Actually, in reality, Dolly is an open source large language model, whereas the large language, something like OpenAI has miscomprehended as something else, right? And here there is another example that I've provided. How old is Queen Elizabeth II? So here the LM might provide the correct age of Queen Elizabeth based on the current year. However, it doesn't independently verify the accuracy of this information, and relies on its existing data, right? Again, in this case, Queen Elizabeth's date of birth could be fixed, but there could be some other values, some other data points which may not be fixed, right? And which could make it more outdated and not so reliable as well. So when it comes to dynamic databases, right, if there is absence of verification, then that becomes a very big bottleneck for LLMs to provide reliable outputs. And that's where something like retrieval augmented generation could come into picture, or even some other techniques could come into picture apart from RAG. Will definitely be helpful. We are going to talk about it. But in short, when we talk about the contextual awareness limitations, there could be troubles with inaccurate or false information. There could be trouble with sensitivity of input wording. The way you ask the question can completely change the answer that is provided by the LLM, right? And right now, with the existing LLMs that we have in the market, there is an absence of verification mechanism. So we are also going to talk about how this verification can happen. And there are some ethical concerns as well. And there is always a limited contextual memory. When I say limited contextual memory, right now, if you look at something like ChatGPT or even the llamas, they have very limited contextual tokens that they can carry. For example, I think in the case of ChatGPT, it can carry it at the maximum 32K tokens or 16K tokens. And when I talk about llama, it can carry up to 2000 or 4000 tokens. And there are other, again, I'm not very sure about the exact token length, but they have a limitation of the token length, right? And they can't process the context beyond that memory. So that's where there is a huge limitation, right? And apart from that, LLMs are often creative, but could have incorrect responses. The same goes to this, right? Here, it has cooked up a nice story about Databricks Dolly, but when we look at it in reality, it has been really creative. It has given a absolutely comprehensive answer, but in factuality, it is not correct, right? So that's what this particular point is trying to comprehend. LLMs are often creative but inaccurate with responses, and there is also a lack of common sense understanding, right? In most cases, you end up getting information that is more robotic, and that lacks a lot of common sense as well. And so, for example, if I have to talk about that, let's say again, here, can a cat lay eggs? No, cats are mammals and do not lay eggs. This demonstrates LLM's ability to provide answers based on common sense and factual knowledge. But this is a good example that I've given where it is able to answer correctly, but there are several cases where it lacks common sense, right? I would love to give some of the examples here. But that's where, like, I'll probably, like, take a pause here in terms of limitations of contextual awareness. And when we talk about how do we improve, right now, the thing comes to how do we improve um, these limitations, or how do we avoid these limitations in the process of solving problems with generative AI or even large language models, right? So that's where when we get there, there are a couple of solutions out there. One could be whenever we talk about any large language model, right? We could end up training from scratch with all the factual data that we have, of a particular industry or even a particular problem. We might end up training it from scratch. That is one way of solving problems. And the second way of solving problems is about fine tuning the existing large language models with certain specific domain specific data or even problem specific data. And there is another thing called as retrieval augmented generation. So I'll probably talk about it in depth in a while. But these are different ways you can improve contextual awareness of any large language model. Now let's dive into how they can potentially, I mean, like, what are the pros and cons of each of these methodologies, right? Yeah.
Yeah, Chanukya, before we proceed, we have few questions.
Yeah, yeah, sure, sure, sure. Go ahead. Yeah.
Okay. So we'll start with this one.
Yeah.
I just noticed Dolly is instruct model. What's difference between fine tune and instruct tune?
Okay. Yeah, we'll probably. Uh, Sorry, what is the difference between?
Or what's the difference between fine tune and instruct tune?
Okay.
I've added in the screen.
Okay, okay, okay. Yeah, yeah, got it. So, yeah, I mean, like, instruct tuning. So, again, I mean, when we talk about instruct tuning, right? So, it is one of the types of fine tuning. That's what I would say. I mean, again, I mean, like, there are different ways you can fine tune a model, right? One is probably like, you're talking about instruct tuning, and there could be a way where I think one of the models that we have built, FE13B, where we have trained it on a chain of thoughts, where we have used a different type of fine tuning. So again, I mean, there are, and there could be something like RLHF fine tuning, where you are using reinforcement learning and human feedback in the loop. So it is one of the ways to tune large language models. Again, I mean, we'll talk about the technicalities in a while. Anything else, Tarun? Yeah.
Yeah, one final question. Like, what is our generative AI strategy?
Okay, so okay, that's a very broad question. But in short, again, I mean, our bigger purpose is to make AI, or generative AI, whatever it is, accessible to everyone, and so that we can solve some of the meaningful problems out there, right? So when I say meaningful problems, it doesn't necessarily need to be business problems, but also it could be very critical societal problems as well. So that's where we are in the process of building some of the things, some of the products. For example, we have built a marketplace as well as a GenAI stack, and we are also open sourcing some of our large language models as well as GenAI stack, as some of you may have seen. If not, like, you can also find it on GitHub and Hugging Face. We'll also share it at the end of the session. But our larger vision is to basically make them accessible to more and more people, so that they can start leveraging these advanced technologies to solve some of the meaningful problems that they face in their day-to-day lives, or even in their businesses, or whatever it is. So that's our bigger focus. But in the process, we are taking several initiatives, be it from the open source standpoint, or even building some of the products that would make them more accessible. But that's where we are on the broader scheme of things. Yeah. Right now, if you ask us, we are heavily investing our focus on large language models, specifically with our GenAI stack and also marketplace. Again, when I talk about GenAI stack, it covers the end-to-end orchestration of generative AI journey, right from data extraction to model deployment. And when we talk about AI marketplace, it very particularly focuses on model deployment, large language model or any AI model deployment, and how do we reliably scale them to millions of requests without really losing on the reliability factor, right? So these are the two areas of focus that we are focusing on at the moment. Yeah,
All right. We have two more questions, but I guess we can cover those later. It's
yeah, sure.
in general questions.
Yeah, yeah, sure, sure. Thanks, thanks, Tarun. So again, just to reiterate, we are going to so far we have spoken about the problems that are posed by hallucinations, as well as also the problems that are posed by the limitations of contextual awareness. Right now, we are going to talk about what are the solutions, and for each of these solutions, what are the pros and cons. We are going to talk about this. And if for starters who are thinking why even we need to think about all these things, right? So at the end of the day, when we are teaching something, we don't just want you to learn them and go back and sit there, right? So we want you to utilize this skill to solve some of the meaningful problems, and to solve it at the extent that it could impact few thousands, few hundreds, or maybe few millions or few billions of people, right? So that's where you need to take these solutions to the production level that can actually solve a problem. And when you're solving a problem, these are some of the industry problems that you might face, you might encounter in solving them. So that's the reason where we wanted to show you the practical use cases, rather than just talking about some of the theory, right? So here, when we talk about how do we solve the problems of hallucination and contextual awareness, as I mentioned, that one way of doing it is you can train the model bottom up with the entire data that you have at the disposal. And the second one is you can fine tune. Again, I mean, fine tuning is different from training, where you already take a base model and try to tune that base model with the existing domain specific data or problem specific data. And the other thing is retrieval augmented generation. So we are going to talk about all these three things, right? In the case of the pros and cons of all these three things, when we talk about pros, right, of training specifically, of course, when you are training a model from scratch with the entire data out there, one of the biggest positives in the entire journey is your model will have rich contextual understanding, because you have actually trained it with your own data, own domain specific data. For example, if I have to give an example, let's say you're building a educational GPT, where it is trained specifically on let's say a particular standard of mathematics. Let's say you're a class 10 student who's studying mathematics, and if you have trained a large language model particularly on mathematics, let's say, and you're calling it as math gpt. So when you train it on your entire textbook of class 10, that means that obviously the model whichever you're getting would have rich contextual understanding, because you have completely trained it on your own textbook. But imagine, instead of doing that, you have trained another GPT where you have taken, let's say, a large corpus of data across the globe, which is fundamentally based on mathematics, not specifically to your teaching standards of class 10, but generally it is trained on math gpt, and or generally with all the subjects. There is a normal model which is trained on large corpus of data, which may or may not have a rich contextual and understanding of your textbook, because it is trained on generic data. And provided it has information of your class 10 textbook, then probably it would have had contextual understanding. But if its training data was exclusive of your class 10 standard, then probably it wouldn't have a rich contextual understanding of your data, right? So that's where, like, just to give you some context, if you're training it on a domain specific data, then it is in all the likelihood it would have rich contextual understanding, and it will be very specific to your particular problem statement, right? And if you apply it to a class 9, or let's say to a engineering mathematics, it wouldn't apply. Why? Because you have trained it on a very specific standard of class, and it would only be applicable for that. And then if you ask anything beyond that, it has no context about it, so it will be very domain specific. Those are some of the pros, as well as when we talk about the cons, right? Now I spoke about very specific small data set, but when I talk about cons, if you're operating at the very highest industry standards, obviously when you're training everything from scratch, especially a large language model, and if you have few terabytes or megabytes of data, you end up investing a lot of time in training the model. You end up spending a lot of money and resources in terms of training this model, and also the data pre-processing and also expertise needed will also be heavy. And all being said, will there be a hallucination or not? Obviously, I mean, the large language models might end up still hallucinating, because that's something that you can't remove out of the equation, right? And that is about the training. So it will have rich contextual and understanding as well as domain specificity. But the problem is, it might end up costing you more. It might end up taking you more time to be able to do that. And the time and cost is very subjective based on the problem to problem, and the magnitude of the data you have. But in general, when you're talking about scale, of course, it's going to cost you a lot, and it's going to take a lot more time than what is expected. So when I talk about fine tuning, it's in terms of the pros, right? Obviously, like, when we talk about the relevance of the LLM outputs, right, it would definitely improve the relevancy of the LLM outputs, because you have already taken a baseline model. Let's say, for example, I take an example of Llama 7B, okay, which was built by Meta, Facebook. So if I take that particular model and train it on the entire mathematics of NCRT. Let's say NCRT is NCRT class 1 to class 10 in India. Let's say if I have trained with all the textbooks of mathematics from class 1 to class 10, then obviously, whenever you ask a particular question about any mathematical concept in the NCRT textbooks, it ends up giving you a much more relevant response. And also, when I talk about the time it takes to be able to tune such a model is much lesser. And also, there is a cost efficiency aspect as well. And you end up getting a very custom model that is specific to this particular problem statement, right? Here, I'm taking an example of tuning a particular large language model on top of class 1 to class 10 in NCRT syllabus, which is used by the Indian board, right? Indian state board, basically. And obviously, the cons are, it still hallucinates, and data pre-processing takes a lot more time. And also, you need a solid expertise to be able to do this. And that's when we talk about retrieval augmented generation, that's when, like, researchers have come up with a new technique like retrieval augmented generation. And that's where, when a query is given to an application, let's imagine we have built a generative AI application. And here I'll take an example of NCRT mathematics itself. And a student has asked a query about a mathematical concept in one of the classes in NCRT. And what the application does is, it goes to the vector database and tries to find the nearest context in the vector database and vector embeddings. And what it does is, it actually accumulates that context and provides it to the LLM. And the LLM would then process that particular context and give back a reliable response to the application. And that response is given back to the user. So this is the entire process. So here, what we are doing is, imagine, let's say, here we have vector embeddings of a lot of concepts from class 1 to class 10 in NCRT. And all these contexts are there, right? And then imagine this particular query is related to a particular very particular topic, right? So in that case, what retrieval augmented generation technique is doing is, it is trying to get all the context that is related to that particular topic in one place. And it is stacking that, and it is giving it to the LLM. And then the LLMs are processing that particular context and giving back the reliable output to the application layer. So this is something that we are also going to see in the demonstration right now. So that's about the retrieval augmented generation, right? Here, you might end up reducing the hallucination and also improving the factual accuracy, because you're only providing the most relevant context to the LLMs, and the LLM is providing that response to the user, right? So with that, let me again, I mean, with that, probably RAG is good, but there is always a missing piece, right? The missing piece is how do you get your data to the vector database, and also how do you keep it synced all the time, right? So the thing is, you have to manage this entire workflow as well, end to end, in a synchronous way, so that your LLM gives up always a reliable output. So that's where you need something like a GenAI stack, which is an end to end LLM framework that allows you to provide that reliable LLM outputs, as well as ensures an end-to-end orchestration. I mean, and also provides you that end-to-end orchestration engine that helps you to process the entire information, and also keeps you up and running with the by giving the jump start with the generative AI journey, right? So with that, I'll probably leave the floor to Shreehari. Maybe if we have any questions, I'll be happy to take it up. Tarun. Yeah.
Yeah, we have one question.
Okay. Yeah. Go ahead. Yeah.
Yeah. Uh, how is fine tuning cart efficiency? It requires compute cost to find the model.
Sorry. How do?
Uh, how is fine tuning cost efficiency? It requires compute cost to find the model.
Yes, obviously. I mean, I wouldn't say it is totally uh, like 100% efficient, but when we are comparing with training versus tuning, right? Definitely tuning is a bit more cost efficient. And when I talk about RAG is even more cost efficient than fine tuning, right? So these are the three different aspects that one need to consider when they are building some state of the
Okay.
art AI infrastructure, or even solving state of the art AI problems in their respective industries. So obviously, I mean, I'm not saying that fine tuning is super cost efficient. It's relatively cost efficient than training, and that's where, when we talk about retrieval augmented generation, it is even more cost efficient than fine tuning. Yeah. Anything else?
Yeah, we'll take one last question.
Yeah.
Like any tips to avoid hallucination? And follow up to that, there was some answer same. Usually LLM hallucinate when it doesn't have enough data on the given prompt. So do you want to add a few more points on how to avoid hallucination?
Okay, got it. So one of the ways to enhance factuality and reduce hallucination is probably RAG, right? So that's where here, as I mentioned, you're giving the most relevant context to the LLM and allowing it to process to provide the reliable output to the user, right? So this is one of the ways to do it. I'm not saying this is the only way. There are other ways of doing it. And again, I mean, it's a valid point. Sometimes you may not have required context, and at that time, it's all right to say to the user that, hey, I don't have the information. Okay, because it's all right to not give an answer rather than giving a wrong answer. So and that's how you can do, actually, even on GenAI stack. When you look at it, if there is no relevant context that is there in the vector database or at the source, then it ends up throwing that, hey, I don't have the answer for this question. So I think it's all right to give that. Yeah. Anything else?
Like I'll add one point in this context. Like
Yeah,
one of
please.
the tip can also be that you need to check with different prompt techniques as well. And one of the most relevant prompt technique for avoiding hallucination is few shot prompting, and it will help you with how you can avoid hallucinate by providing few context. So that's how you can avoid. So this is one such technique, and obviously you have RAG as well.
Yeah, no, absolutely. No, I think that's super relevant. Thanks for adding that, Tarun. And also,
We
I mean,
have
yeah, good. Yeah,
Yeah, we have one question, but it's related to enterprise and mindset. I hope we can take that at the end rather than taking it now.
yeah, sure. That's fine. So I'll probably leave the floor to Srihari now. Again, I mean, with the GenAI stack, what it is supposed to do, again, when we talk about the problems that we have already discussed, it technically teaches a business language, or the context to LLMs, and also in the process, it minimizes hallucination and enhances factuality. And there is one problem that we spoke about, that is about the data privacy and security. That's where some frameworks like GenAI Stack can be deployed on the secure environment on your local machine, or even on your own servers. So that gives the additional cushioning on data privacy and security. So with that, I'll probably leave the floor to Shreehari. Yeah.
Okay,
Yeah,
so we have Shreehari on the screen, and Shreehari, if you could proceed with the session.
yeah. Thanks, Tarun. Yeah, let me share my screen. Is it visible?
Yeah,
Cool.
it's visible.
Yeah,
The Google
yeah,
Collaborate.
yeah. Yeah, okay. So hi, myself Shreehari. So I'll just give a simple demo on how you can use GenAI Stack from, let's say, if you want to create some experiments or a prototype, and even or else if you want to use it for in a production environment, I think it will fit in every places. So the first thing is, of course, you have to
Shreehari,
install
one
Gen.
second. Hello.
Yeah,
Before you can
hello.
proceed, can you zoom the screen? It's very small.
Oh, sure, sure. Yeah,
Yeah,
is
okay,
it
now
enough?
it's visible.
Is it good enough? Yeah,
Yeah,
cool.
yeah.
Yeah, so as I was saying, first you have to install GenAI Stack. Currently, you can install GenAI Stack directly from her GitHub repository. So here we are installing the latest version of the GenAI Stack. If you want to install a specific version, you're free to do so by adding, at 0.2.0, which is our old version. So, but here we are installing the latest version, that is 0.2.1. So along with that, we are installing some external dependencies. So in our first use case, we'll be chatting with the documents where in a directory we have some documents which I'm not aware of, and we'll be chatting with that. Since it's a PDF document, we are installing some dependencies like unstructured. And to verify the GenAI stack version that we have installed, you can just run this command, and you will see a GenAI stack coming up, and even the version that is installed. So the first use case is document chat. Uh, there are different components we'll be using throughout this demo, like embedding. So this embedding component is being used to convert any data into a vector embeddings. So if you ask why vector embeddings, it is one of the efficient ways for a model to understand the data, which is nothing but zeros and ones. And ETL, this component is particularly for pulling this whole component. What it does is it pulls the data from the source. In our case, that is a document, directory of documents, and then convert it into embeddings and dump it into the database. Then we have a memory component. So this memory component, what it does is it temporarily stores your chat history, basically the interactions that you do with the model, and the model itself. Model is nothing, the LLM model that you want to use. So all these components, again, prompt engine. So it enables a specific behavior for the LLM model, so that it doesn't go out of the league, or doesn't pass whatever we want to do with it. And the retriever is used for pulling the data from vector store or vector database. And the stack, so this stack is nothing but it is used to create a network between the different components we are using. And of course the vector store, or the database, it is for storing our vector embeddings. So to know more about GenAI stack, you'll find you'll find that in our documentation in this particular URL. So first we'll be importing a few modules from the GenAI stack. The first one is the embedding, and then it's module and conversation buffer, the OpenAI GPT 3.5 model. So the reason we are using GPT 3.5 is just to make sure that anyone can easily use it. So there are other models also we support, like Llama 2, and or else any model from Hugging Face, or even GPT for all model. And we'll be importing prompt engine, the the retriever for retrieving from the database, the stack. And so this VVADB is nothing but a vector database. Uh, we even we support different databases like VB8, ChromaDB, Redis, and some other databases. So to experiment, we'll be creating one directory in which is this will be the path to the directory, and then we will download few files, that is broadcast technicians and bankruptcy events. So I have no idea about what these files are, but I'm downloading. So once it is downloaded, so here I'm assigning the value of an OpenAI key to an OpenAI API key variable, and then the target files directory where all the files are stored. Uh, Coming to this, so what our GenAI stack is, the way it is built is to make sure you just declare few things or configure few variables and pass it on to a stack, basically GenAI stack, so that the GenAI stack takes care of rest of the things and you can just use it. So to start with, we'll be using for embeddings, we'll be using this MPNet based V2 model. So this is totally customizable. If you feel like you're using some other models, you are feel free. I mean, you are free to do that. So once that is so, any additional arguments or quarks that you want to send to this particular model, it can be done by passing a dictionary to this key, and then and encoding the quarks, that is normalized embeddings, is something that we is required for this model. And then we'll set up our ChromaDB, that is our vector database for this demo. And so ChromaDB is basically in-memory database. Also, if you so it supports persisting the database, I mean the data into a local storage. That if you want to do that, you can just add it here. I mean yeah, pass an argument here saying that persist path and where you want to do it. And then so we'll be setting up ETL. So ETL is nothing but where so we are saying to this component that we our files lies in a particular directory, and we want to use it. Since in our case it's mostly PDF, we will be specifying that get only the PDFs from a particular directory. And here the name is directory loader. The reason being, it's basically all our PDFs are in a directory. That's why we are using a directory loader. And yeah, so here in space here we are specifying LLM, that is OpenAI GPT 3.5 model. If you want to use GPT-4 or any Hugging Face, any models from the Hugging Face, you are feel free to use it. So we will pass the parameters to this OpenAI model, that is OpenAPI key, which we have already assigned in our previous step. And then we are configuring the prompt engine. So by default, we'll be using a Q&A prompt engine, and there are other prompt engines like Chat, QA, and yeah, some other prompt engines. And then we have a retriever configured and also a memory. So currently we support only a conversation buffer memory. That is, all our conversations are stored in memory. Uh, yeah. And then once, if you see in our directory, we have these files that are stored, the ones that we downloaded. Then we are stacking all our components together to make sure they work with each other. So in this step, what it does is it sets up the ETL pipeline where it gets the data source and convert it into embeddings, then dumping it into the database, and all those things are done. So then we had just created a simple chat interface kind of thing in a CLI manner. So my first question was, what is the job description of broadcast technicians? And the response was, a broadcast technician is responsible for the setup, operation, and maintenance of the equipment used in television and radio broadcast. Basically, this was picked from the document that we had given. And then later I wanted to know what are the tasks that broadcast technicians do. And then the model just gave it directly from that. It just picked the points that are, I mean, the data that it got from the document, and it returned it on some points. And then let's say we also had one more PDF of all the bankruptcy events, and I wanted to know in an alphabetical order. So what I did is I asked for bankruptcy events, and I added listed in an alphabetical order. So it gave me all the bankruptcy events that are present in the PDF, and it just listed it to me. Yeah. So this is one of the use cases, that is document search, and the applications are like, let's say I'm working in a legal company, and I want to and the data is so crucial that it is okay for the model to not give an answer rather than giving a hallucinated answer, which can go haywire. And that's where you can use with a few lines of code, you are ready to interact with the whole documents you have. One more application is web search. So let's say you have a website and you want to interact with it, and you don't want to go through the whole website, or it can be even a documentation. In that case, what you can do is you can use GenAI stack in the same way, configure it where we have used Hugging Face, one of the Hugging Face model from the Hugging Face for converting it to embedding. Then we have used ChromaDB. Then we have set up the ETL, and in this ETL process, we have said since it's a web page, we have asked it to use a web-based loader and pass the web path. So this can be a single URL or a multiple URL. So if you want to pass a multiple URL, you can add it like aiplanet.com. Instead of aiplanet.com, maybe I'll add my own, not my own, the website of the GenAI stack documentation URL. So I have just added it, and it will get all the data from both the URLs and store it in a vector database in the background. And you don't really have to wait for the whole process to complete. So then we'll be configure our LLM model, then the prompt engine, retriever, and memory, and then we are stacking all our components together, whichever we require. And once our stack is ready, we are asking our model, basically the retriever, which interacts with the model and also the data, and which makes the model and the data interact with each other and give you relevant answer. So my first question was, what does AI Planet do? And the response was AI Planet. It even said that its previous name was DeFi. And
Hello, Shreehari.
yeah,
There is one question,
yeah,
like,
yeah, sure.
hey, how do you handle layout complexities in PDF?
Layout complexities. So it is basically, there are different ways you can handle the layout complexities. Let's say you have an image. So when it's an image, the loader will be responsible for extracting that particular image, and then still convert it into an embedding, and then
Um,
store it once. Yeah, yeah, that's how basically it happens.
so for that, we had a follow-up question by the same guy. Uh,
Mhm.
the previous was like, hey, how do you handle layout complexity in PDF? Then, like PDF, having tables or guidelines.
Yeah, so even if it's a table, what it does is what it does is basically it extracts the table and stores in a vector embedding. So how the extraction happens is something the loader ETL will take care of, and the one who is working on that really don't have to worry about that. Yeah, is that fine?
Oh, okay. So I hope that answers the question. And we have one last question before we can
Sure,
proceed.
sure. Yeah.
Uh, can you please tell what happens in ETL?
Yeah, so ETL is nothing but a short form for extract, transform, load. Basically, extraction is nothing but extracting the data from our source. That is, in our case, that is a directory, I mean, the folder in which all our files exist. And then we are transforming that particular data, that is a raw text, into a vector embedding. And then we are, storing it. Loading is nothing but storing it into a place. In our case, we will be storing it in a vector database, that is ChromaDB in our case. Yeah, that's basically ETL. Yeah,
Yeah, we can proceed.
yeah, cool. Feel free to shoot any other questions you have. And so yeah, once we had a stack setup, then we created a chart interface with the same old code. What we did is we asked for a set of questions. What does AI Planet do? And for that, it gave an answer directly from the website without anything externally hallucinating or something. And then we asked for what all courses it has. It mentioned the specific courses that the website provided, like data science, machine learning, deep learning, and it didn't provide any other courses related to maybe what is a Java, what like JavaScript courses or anything else. Yeah, so that's basically, these are like some simple applications to start with, and it can be scaled to other like production grade use cases as well. Yeah. Are there any other questions, Tarun?
Uh, okay, so there is one. What is? Thanks for answering question. It would be nice if you light on how LLM understand table or bullet point text, as I know LLM being trained on sequence of data.
Yeah, true. So in this ETL process, when we are converting it into an embedding, so we don't really, differentiate, make it differentiable. We don't make it really a differentiable state, so that for the it won't be differentiable for the model. That is, this is a table and this is a normal raw text. So for model, both are the same when we have stored. That's where ETL process is simplified with GenAI stack. Yeah, I hope that answers your question.
Yeah. Do we have any more question? Like Chanukya, we have two questions to cover. Is the demo done?
Yeah, yeah. Demo is almost done. Yeah,
Okay. Sure, I'll ask this question. If
yeah, sure.
where is the value in generative AI in the short, medium, and long term?
That's a very good question. So so the value in a short, medium, or long term, I would rather take it in this way. In a short period of time, it will be able to, answer the questions. Let's say you have a corpus of data, and let's say, if you have to analyze each and everything, what the document is doing, rather you can use generative AI there. Let's say in high courts there are so many, let's say in courts there are so many cases pending, and if a judge has to analyze each and everything, it would be like forever for the the judge to understand what the context is about. Whereas with generative AI and with RAG, we'll be able to reduce the amount of time without the model has to be trained on the corpus of the data that the judge has. In a long term, it is something, as an individual, I'm excited about where this generative AI will be taking us. Yeah, hopefully we can we'll explore it together. Yeah, maybe Chanukya can give more answers, add something on top of it.
I think I more or less agree on that. So yeah, I mean, right now, I think people are still figuring out how it can help and disrupt different industries. I think everyone is in the exploration phase. Right now, everyone is more focused on the compute side of things, and also figuring out the infrastructure layer and other things. It hasn't, the application layer or the application players are still figuring out where exactly they can fit in, and what kind of value proposition it can have on a short run and a long run. Right now, I think one of the biggest some of the biggest use cases that it is helping is in the customer support chatbots, or even retrieving information very effectively, be it with AI powered search or question answering kind of a thing, right? I mean, that is something that has disrupted already in the short run and in the current run exactly. But I think in the long run, we would end up seeing a lot more applications on the healthcare, education, fintech, and in different areas. Different industries will get disrupted. Uh, we are also still exploring what are the other use cases it can potentially have an impact. I think it's we just need to wait and watch. Yeah. So
We have one more question. Like, what is the enterprise mindset for successfully adapting GenAI, like Amazon Alexa, Google Search, now Google Bard, Netflix, Spotify recommendation? Now, I guess this is GitHub Copilot. So many more to come.
Okay, what is the enterprise mindset for successfully adopting GenAI? So I think the first way is I think I would probably emphasize on solving some core business problems, right? So that's where we have come up with some framework called as again, I mean, we haven't come up with that framework, but I think we have read about a framework called as SPAR framework, where it talks about just give me one moment. I'm just running through that. So we where we talk about situation, that is the current scenario. When we talk about the current scenario, there could be some key business challenges, and it's called a SPAR, right? So SPAR is nothing but situation, possibility, action, result. So this is something that we would probably recommend any enterprise who is thinking of actually adopting generative AI to consider. So let me just probably quickly show the screen, right? What is your current situation? What are your key business operations and challenges? What are the areas where you can possibly apply generative AI and even validate that particular pain points, right? And then you can probably think about what are the action items, what are the next steps and potential barriers, and you can already talk about potential benefits that you foresee. So if you can put this on a simple document or on a pen and a paper to see how it can actually solve your existing problems or existing business problems, I think that would be a good starting point, rather than jumping with the FOMO and with the fear of missing, or even with the fear of losing out, right? It's more important that you specifically think about what is the business problem that you have at hand and how you can potentially see value with generative AI, because not all problems can be solved with generative AI precisely, and there could be some problems which can be solved with some other simpler approaches than going with generative AI, right? Because we must also admit that generative AI is very costly, and we should also think and tell to ourselves, right, that like, if you have to break a glass, you don't always necessarily need to use a missile to break it, but you can always use a hammer, or even a simpler tool to break it, right? So whenever we are thinking about solving the problem, we have to think about its last mile impact in terms of what kind of value proposition it would provide, from key performance indexes to the revenue potential and other things, and also the direct value on the monetary benefits, or also on the employee efficiency benefits and other things. So that holistic picture actually helps you to drive the generative AI initiatives much more effectively for a longer run than looking at a short term hit. Yeah, I hope that helps, addresses the question. Yeah.
Okay, so I hope that answers the question. And until we wait for the next question, uh, there are few things we need to discuss. The first thing is GenAI Stack is open source, and we are looking for the contributors. And if you feel that you can add more examples to the use cases, you can head over to the GenAI Stack. I'll share the link in the chat. And the second update is regarding the Oktoberfest. So if you are part of open source community, then you have heard this word before, Oktoberfest. So giving a small insight about Oktoberfest, it is a 31 days big event where people who wants to get started with open source, they look into the repository and they find different features or bug, and they solve this issue by raising a pull request. And we GenAI Stack is also part of Oktoberfest, and we are looking for the contributors for this open source community during the Oktoberfest month. And we have one event which we have planned, and this will be in collaboration with MLX and also Oktoberfest. During this event, what we will be doing is we will do a walkthrough to the data types which are available in GenAI Stack. And once you are familiar with the data types, we will also have a few use cases example. And by this example, what we will be doing is we will work on few examples, and this example can be how you can chat with web page, and also how you can chat with PDF, or any other data type. And once you're familiar with this, we have few issues which we have added it in the GenAI Stack GitHub page. So you can work on any of those issues and you can get started with your open source journey. So we'll be sharing the updates on the October 1st via newsletter, and please stay updated. And as I mentioned, here is the link for the public open source repository of GenAI Stack. You can look into documentation, and if you feel you need to improve the documentation, please feel free to check the issues section and add your issues, and you can improve the documentation. So these are the two things that we had to discuss during this session. Shreehari, do you have any more thoughts that you wanted to add?
Yeah, I think that the same whatever you mentioned. Just to add the same, anyone can come and contribute to the project, and they can shape the future of this project and shape the future of what generative AI can do. Yeah, just want to request anyone who can contribute, maybe via documentation, coding, or different use cases, or if they are facing any issues, they can feel free to create, or any bugs, feel free to create issues, and yeah, feel free to contribute. Yeah.
uh, Chanukya, do you want to tell something related to this one?
Yeah, no, nothing much. I think thanks a lot.
Okay,
Tarun,
we'll wait for 2 more minutes.
yeah, yeah.
Please feel free to ask any more questions related to GenAI Stack or LLM in general.
And also, I think the GenAI Stack public repo is also shared. I mean, feel free to give your feedback, and we would love to get your inputs on that. And feel free to play around with it. I think it gives you that feel of product on how a production environment works, and also how you can actually work on production level use cases using stacks like GenAI Stack. Would also love to get your contributions on how to improvise it further to be able to impact many more applications, and thereby many more people out there. Yeah.
Uh, to answer Shankar question, like, can you share the source code of example shown? I have added a link in the screen, the bootcamp slash LLM bootcamp. You can check the module 14. The Google Colab notebook will be visible. Okay, so there are no more questions, and I thank Chanukya and Shreehari for joining this session and sharing your expertise on how LLM works and about the fine tuning. Okay, uh, I guess we have already replied.
Yeah. Thank
Okay,
you.
so thank you again,
Yeah.
and I hope we'll have one more session shortly on how to get started with GenAI Stack via open source journey through Oktoberfest. So until then, thank you so much.
Thank you. Thank you. Yeah. Bye.
Thank you.